This lesson is on solving systems by inspection. Sometimes we can determine the number of solutions that a system of equations has by simply observing and drawing conclusions from the equations. This is called inspection. For example, if we know that two equations have the same slope but different y-intercepts, then the system has no solution. Because we know if they have the same slope, that means they're parallel like this, which means they will never intersect and therefore have no solution. On the other hand, if two equations have the same slope and the same y-intercept, then the system has infinitely many solutions. And of course, that graph, if it's the same slope and the same y-intercept, then it ends up being the same line. And I'm just making it a little bit thicker there, so that kind of might make sense for you. Okay, determine how many solutions each system of equations has. Be sure to explain your thinking in the space provided. And we're not going to do this part right here. So if we look at this first set of equations, this is a systems of equations, and we look at the slopes. We're looking at the slopes and we're looking at the y-intercepts. What do you notice about the slopes? If you say that the slopes are the same, I would write that down, same slope as a note. But the y-intercepts are different because one is positive and one is negative. What does this mean? How many solutions would we have if they have the same slope? Go back to your notes if you need to. Same slope means the lines are parallel, and therefore there will be no solution. Number 2, how many solutions does the system have? Well, I would suggest that when you look at these two equations, that you notice they're not in slope-intercept form, and so therefore I would suggest that we solve each of them for y so that it becomes in slope-intercept form. So the first thing we're going to do is we are going to subtract the 7x over to this side. So we have positive 3y equals, and when the 7x is subtracted to the other side, it becomes a negative 7x plus 10. Well, we still need to get y by itself, so we need to divide by 3 right here all the way across. So we end up with y equals, now negative 7 divided by 3 is not a nice integer, so we're just going to leave it as negative 7/3 x plus, and 10/3 is 3.3 repeating. Let's do the next one. Move the 7x over, so we have 3y equals negative 7x plus 30. Divide by 3 all the way across, and we have y equals, again, negative 7/3 x plus 30 divided by 3 is 10. So what do we notice here? We are looking at slopes, and then we are looking at y-intercepts. Well, the slopes are the same, but the y-intercepts are different. And so therefore, if the slopes are the same, different y-intercepts, this is going to be no solution. Number 3. How many solutions does this have? Well, look at the first equation, y equals x plus 1. Remember, this is 1x plus 1, and this was negative 1x minus 1. So the slopes are actually different here, and the y-intercepts are different. So since the slopes are different, that means the lines are actually going to intersect. And when they intersect, we end up getting 1.1 solution. Okay, number 4. Now the first one is already in slope-intercept form, and we can see that the slope is 2, or 2 over 1. But the second one we need to solve for y, so we're going to move this over. So we bring down the positive 4y. When the negative 8x moves to the other side, we end up with a positive 8x, and then that was a positive 2 that was already on that side. Then we divide by 4 all the way across. And we end up with y equals 8 divided by 4 is 2x plus, and 2 divided by 4 is 0.5. Now what do you notice here? Look at the slopes And then look at the y-intercepts. The slopes are both 2, or 2 over 1, and the y-intercepts are 1/2 and 0.5. But 1/2 and 0.5 are exactly the same number. So therefore, this is the exact same equation. It's the same line. So we are going to have infinitely many solutions. Okay, on the next section, match each equation on the left with the equation on the right that would make a system with infinitely many solutions. So if we have a system that's infinitely many solutions, that means that the lines are actually they overlap. They're the same line. So I would suggest that first you go through and any of these equations that are not in slope-intercept form, that we go ahead and solve those for y first. Okay, so starting with this one, we're going to move the 2x over to this side. So I have 3y equals negative 2x plus 6. Divide by 3 all the way across. And I end up with y equals a negative 2/3 x plus 6 divided by 3 is 2. Let's look at the next one. First step, move over the term with the x. So we have positive 3y equals, and the negative 6x when it moves to the other side is a positive 6x plus 6. Divide by 3 all the way across. And y equals 2x plus 2. Okay, let's go over here to b, and let's do the same thing. We're going to move over the 3y. So we have y equals negative, not move over the 3y, sorry, move over the 3x. So y equals, and when the 3x moves to the other side, it becomes a negative 3x plus 6. Now notice that in front of the y, that's a positive 1, so we're good to go. There's nothing else we need to do there. Let's do the same thing for the equation underneath. We're going to move the term with the x over. So we have y equals, when it moves over, it changes signs, negative 3/2 x plus 2, and the same thing, there's a 1 in front, so we're good to go. Now, we are going to look at the equations on the left and the equations on the right, and we are going to match them up. So first of all, looking at number 5, we've got y equals negative 3 over 2x plus 2. So we go over here and we look, and right here we have negative 3 over 2x plus 2. So number 5 with letter C, those are the same line, so that would give us infinitely many solutions. So we're going to put C here. Okay, number 6, we ended up with y equals negative 2/3 x plus 2. So look over here, and if you see it's A, very good. The next one, y equals 3/2 x plus 2. Right here, D. Number 8, which one would that one match up with? Letter E. And number 9 matches up with letter B. I forgot my Apple pencil to use, so I'm sorry. I'm doing the best I can writing with my hand. All right, for each equation below, write your own second equation that would make a system with no solution. So if it's going to be a system with no solution, that means they're going to be parallel lines, and parallel lines have the same slope. So this is actually pretty easy. All of us should start out with y equals. We're going to keep this slope because we want the lines to be parallel, but we get to pick any other y-intercept that we want. So you could put plus any number or minus any number. It doesn't matter. I'm just going to pick plus 2. Okay, if you want to pause it and try number 11, you certainly can. On this one, everybody should have y equals negative 8x, and then, because that's the slope, so we want to keep the same slope, any number after that. Minus 4 is what I'm going to pick. All right, number 12. Now, we want to write an equation with the same slope, but we can't really see the slope right now because it's not in slope-intercept form. So we are going to solve this for y. We are going to move the 4x over, so we end up with y equals negative 4x plus 7. So the slope is negative 4 over 1. So we write y equals negative 4x, or negative 4 over 1, x is fine. And any y-intercept after that will still be parallel. So I'm going to put plus 6. All right, almost finished here. Number 13, the sum of two numbers. Sum means to add two numbers, so the sum of two numbers is 8. Is it possible for the sum of two numbers to also be 10? Why or why not? Well, if we were to try, let's say 6 plus 2 equals 8, is 6 plus 2 10? No. And you could keep trying, but any two numbers that add up to 8 are not also going to add up to 10. So no. Number 14, our last one. The sum, again, of two numbers is 8. Okay, so we're starting out the same way. Is it possible for the difference, what does difference mean? Subtraction. Is it possible for the difference of the two numbers to also be 8? Why or why not? So let's think of some options here. So 4 plus 4 is 8. Is 4 minus 4 8? No. All right, how about 6 plus 2 is 8? Is 6 minus 2 8? No. Can you think of a set of numbers that would work? If you thought 8 plus 0 is 8 and 8 minus 0 is still 8, so yes, this would work. All right, that is the end of this.